Let us talk about why Apache Solr skills are so valuable. Solar powers full tech search for some of the biggest companies across the globe. Whether it is e-commerce, enterprise search, or a large-scale data handling, Solar provides the backbone for efficient, scalable search solutions. This demand has created lucrative career opportunities for solar professionals. Let us talk numbers. In the UK, the average salary for a solar administrator or developer is around £65,000 per year. That is not just about competitive. It is a reflection of the high demand for professionals skilled in solar. Companies are looking for experts who can set up, manage, and optimize solar cores, ensuring top-notch performance for their search functionalities. And keep in mind, salaries can vary depending on experience, location, and the size of the organization. In major tech hubs like London, you might see even higher offers, especially if you have expertise in integrating Solar with other frameworks like Python, FastAPI, or cloud-based solutions. To learn these roles, you will need skills like setting up and configuring Solar cores, managing indexing and schema design, optimizing query performance, integrating Solar with other tools and programming languages. If you're just starting out, don't worry. There are plenty of resources to help you build your expertise. So, whether you are just starting your tech career or looking to specialize, Apache Solr offers incredible opportunities with a strong demand and competitive salary. It is a field worth exploring. If you're working with Apache Solr, you have probably wondered, how do I size my instance properly and what exactly is a Solr schema? Sizing your Apache Solr instance involves planning for your data volume, query, load, and indexing needs. Let us break this down. First up, data volume. Ask yourself, how much data will you be indexing? The amount of data directly impacts how much memory and disk space you will need. Next is query load. Consider how many queries per second your Solr instance will need to handle. Higher query loads demand more CPU power and RAM for efficient processing. Then there's indexing load. If your data is updated frequently, you will need to allocate enough resources to index new data without slowing down search performance. For larger deployments, consider using Solr Cloud for distributed search and failover. Solr Cloud improves reliability and scalability but requires additional resources to support replication and load balancing. Now that you know what to consider, here are some best practices for sizing your Solr instance. Memory allocation. Allocate about 50% of your system RAM to Solr, up to a maximum of 64 gig. Make sure to leave room for other applications. Use SSD storage for faster read and write speeds, especially with large data sets. Set up Solr Cloud replication to distribute load and improve availability. This ensures your system stays reliable even under heavy traffic. Alright, let us shift gears and talk about Solr schema. A Solr schema is a configuration file that defines how Solr indexes, stores, and searches your data. Think of it as the blueprint for your Solr instance. Let's talk about some key components. Number one, feeds. Feeds define the data attributes Solr will handle. For example, you might have feeds for title, content, and date. We also have the feed types. Each feed has a type, like string, text, integer, or date. Feed types determine how data is stored and indexed. We also have analyzers. Analyzers process text feeds for searching. They handle tasks like tokenization and stemming to improve search accuracy. Likewise, we have copy feeds. Copy feeds lets you combine multiple feeds into a single searchable feed. This can be super useful for creating composite search fields. When sizing a Solr instance, consider data volume, query load, indexing load, and redundancy. Follow best practices like allocating 50% of system RAM to Solr and using SSDs for storage. A Solr schema defines the structure of your data, including feeds, feed types, analyzers, and copy feeds. Understanding how to set up your schema is crucial for managing your search index effectively. What is Solr schema? Like we said earlier, a Solr schema is like the blueprint of your search index. It is defined in the manage schema.xml file, where you specify the field types and the structure of your data. This file determines how your data is indexed, stored, and retrieved. You can see example snippets of managed schema file shown on the screen. Fields like title, content, and ID are defined with attributes like index to true, which means the field can be searched, and stored to true, which means the field's value will be saved and retrievable, perfect for displaying it in search results. To define fields in the managed schema file, use this structure: set the field name, define the field type like string, text, or integer. Use attributes like indexed and stored to control how the field behaves. This process ensures that your data is both searchable and retrievable in the way you need. Not comfortable editing XML? No problem. You can create and manage your schema directly in the Solr admin UI. Here's how. First, open the admin UI by visiting this URL. Select the core you want to modify. Under the feed section, click Add Feed. Enter the feed name, select a type, and configure attributes like indexing and storage. For example, you might define a title field as string and make it both indexed and stored. You can also create a new field type in the field type section, specifying how your data is tokenized and indexed. So once you've added your field or updated the schema, go to the core admin tab and click reload, just like I did here. This applies changes to your core, so they are live in your Solr instance. The manage schema file defines your Solr schema, including file types and attributes. Use the Solr admin UI for a more visual approach to managing fields and field types. Always reload your code after making changes to apply them. Following these steps ensures your Solr instance is configured for optimal performance and accuracy. In Solr, feed types define how data is indexed, stored, and queried. Choosing the right field types can significantly impact your search performance and the size of your index. Let us start with the first field type, which is text general. The text general field type is designed for full text search. It breaks text into individual words or tokens and supports text analysis, making it perfect for searching keywords within a document. Here is what text general stands for. Text is broken into smaller units, enabling better search relevance. Text analysis. This helps with stemming synonyms and case insensitive. Now let's talk about performance. The pros: it is optimized for search relevance and flexibility. The cons: it is resource intensive, requires more CPU and memory for both indexing and querying due to the text analysis and tokenization process. Another thing to keep in mind is index size. Tokenization and metadata for search analysis make the index size larger, which can be a consideration for high volume datasets. Next, we have the string field type. This one is simple. It doesn't tokenize text and store the entire string as a single value, making it ideal for fields that require exact matches like IDs, username, or product SKUs. In terms of performance, the pros are clear. Faster for exact matches like filtering and sorting. efficient for non-searchable fields that don't need tokenization. But it couldn't. It is less flexible for full-text search operations, so it is not suitable for keyword-based searches. Finally, the index size. Since string does not involve tokenization or additional metadata, it results in a smaller index size, saving storage space and improving efficiency. So how do you decide between text general and string? Use text general for fields that require full text search like content or descriptions. Choose string for fields needing exact matches like IDs or tags. To recap, text general is great for flexibility and relevance but requires more resources and space. String is perfect for precision and efficiency but lacks flexibility for keyword searches. Always balance your choice based on the type of data and queries your application will handle. Let us start with how field types affect performance. First, text general. This field type requires more processing because of tokenization and text analysis. Every time you index or query data, Solr has to break the text into smaller tokens, analyze it, and store additional metadata. As a result, this can slow down indexing speed and increase query response times, especially with large data sets. On the other hand, string is a simpler field type. It does not tokenize text and stores it as a single value, making exact matches much faster. So if you're working with fields like IDs or usernames where full text search is not needed, string is your go-to for performance. Now let us talk about how these field types affect your index size. Text general. Text general creates larger indexes. Why? Because of tokenization and the additional metadata Solr stores for search analysis. This can quickly add up, especially with large data sets. In contrast, string results in smaller indexes. Since there is no tokenization or additional processing, only the raw data is stored. This makes it a more storage efficient choice for fields that don't require full text search capabilities. So when should you use text general and when should you opt for string? Choose text general for fields that requires full text search like content or descriptions. Use string for fields that need first exact matching like IDs, product codes, or usernames. Here are the key takeaways. Text general offers flexibility for full text search but at the cost of performance and index size. String is efficient for exact matches with faster performance and smaller index sizes. Choosing the right field type depends on your specific use case. Think about your dataset query patterns and storage requirements. Now, why does schema configuration even matter? Setting up your Solr schema properly is the foundation of an optimized search experience. Here's what it brings to the table. Number one, optimize search performance. Your schema determines how efficiently Solr indexes and retrieves data, ensuring quick and relevant search results. The second point is it ensures accurate data representation. This allows your data to be stored and queried in the right format, minimizing errors and mismatch. Then the third point is it customizes indexing behavior. You can tailor how fields are indexed and stored, giving you full control over your search capabilities. The fourth point is it supports complex queries. A well-configured schema empowers you to execute advanced queries with filters, sorting, and faceting. The last point here is scalability and flexibility. As your data set grows or your application evolves, a properly designed schema ensures your search remains scalable and adaptable. Simply put, a well-thought-out schema sets the stage for a robust, scalable search experience. Now, let us explore some of the most commonly used Solr field types and their specific use cases. Each field type serves a unique purpose in indexing and querying data. Let us break them down. The text general field type is designed for tokenized analyzed text. This makes it perfect for full text search scenarios. such as articles, blog posts, or product description. Next, we bring string ID for exact matches. Unlike text general, it doesn't tokenize or analyze text. It is great for fields like ID, codes, or usernames where precision is key. Text EN is similar to text general but includes language specific analysis for English. This is ideal for applications like blog posts, product descriptions, or any English language content that requires nuanced text analysis. The int field type is also about numbers. It is used to store and query integer values like product prices, user ages, or ratings. If you're filtering results by price range or sorting by ratings, this is your field type. Finally, we have date, which is used for storing and querying date and time values. Whether you're filtering by creating date or sorting by modification timestamps, date fields are a must for time-sensitive data. Let's recap what we've covered. Proper schema configuration is crucial for performance, accuracy, and scalability. Field types like text general, string, text en, int, and dates each serve specific purposes, from full text search to numeric filtering and date sorting. By selecting the right field types, you can optimize your Solr instance for any application, whether it is an e-commerce site, a CMS, or a knowledge base. Let us talk about field types, a critical part of your Solr schema configuration. Choosing the right field type ensures efficient indexing and query. Here is how to decide. Text general. Use this for full text searchable fields like title and content. String. Perfect for exact matches such as IDs or unique codes. Numeric fields. For whole numbers, use int, and for decimals like prices or rating, use float. Date. Essential for fields like timestamps, where date-based filtering is needed. Boolean. Great for binary flags like active or inactive users. Now that we've got the schema sorted, let us explain how our app is being built. We use FastAPI for the backend and PySolr to connect to Solr. First, install the dependencies. Pipe install FastAPI and also PySolr. FastAPI is perfect for handling asynchronous web requests, while PySolr simplifies Solr integration in Python. To connect to Solr, initialize the PySolr client. Here is the code. This connects to your Solr instance and ensures that changes are committed automatically.